Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, so let's have a look at those questions that followed on from the theory we were doing about arithmetic sequence and series. Okay, so the first question is the nth term of a sequence is given by Tn is equal to 5n minus 2. Write down the first four terms. So in many of the questions, it's actually easier if you write out your sequence, okay? Although it may not specifically be asked as part of the question. Okay, so to work out this, I would take down my formula. So Tn is equal to 5n minus 2. Okay, so remember from our theory, our sequences are T1, T2, T3, T4. Okay, that's how we label our terms in a sequence. Okay, all the way up to Tn. Okay, so my first term and therefore would be T1. Okay, so in this one, n is taking on the value 1. So it'll be 5 times 1 minus 2. So 5 ones are 5 minus 2 is 3. Okay, T2 would be n is replaced by 2 minus 2. So 5 twos are 10 minus 2 is 8. T3, 5 threes are 15 minus 2 is 13. And T4, 5 fours are 20 minus 2 is 18. Okay, now what I always do for myself is I calculate that first difference that we talked about, or that common difference D, okay, which is literally the difference between the two terms. So the difference between the terms T2 minus T1 is 5. Okay, and you don't always have to specifically write it out, but you are eyeballing it to make sure that the difference between all the terms 18 minus 13 is also 5. Okay, so if this is an arithmetic sequence, then the common difference is going to be the same. So we're going up in fives, okay? So T5 now is 23. I know that without the formula. T6 would be 28, and so on and so forth. So that's how you write out your sequence. You then write it out as just that, a sequence 3, 8, 13, 18, and so on. Okay, so question 2. Find Tn, the nth term of the following. 10, 7, 4, 1. Okay, so again, if we look at the difference between those two, we are going down 3, down 3, down 3. Okay, so in this one, I would say my first term is 10 and my common difference is minus 3. Okay, I'm going down 3 every time. Okay, it's an arithmetic sequence. I know that because the first difference, the difference is the same. Okay, so if you go to your log tables, there's a formula there for the nth term. Okay, so Tn is equal to a plus n minus 1 times d. Okay, so Tn is equal to a plus n minus 1 times d. Okay, so for this sequence, a is your first term, so it's 10 plus, and we're finding the nth, a formula for the nth term, so Tn, so n stays n in this case, okay? And d, my common difference is minus 3. Okay, so let's come up here and continue. So Tn is equal to 10, okay? So for some people, it's easier to swap these brackets around. Okay, for others, they don't care. Okay, plus minus 3 times n minus 1. So I've done nothing more than swap the order of the two brackets so that you can see it's minus 3 by n is minus 3n, minus 3 by minus 1, minus by minus is a plus, 3 ones are 3. So I get 10 and 3 is 13 minus 3n. Okay, so that's your formula for Tn. Does it work? Well, you should test it, okay? And you can use your calculator for that. So, for example, does it give me T1? Does it give me 10? So if I sub in 1 for that, let me do it here in red so you can see what I'm doing, okay? So to test, T1 is equal to 13 minus 3 ones, so it's equal to 10. That looks good. I'm happy with that. Let's test T3, for example. So it's equal to 13 minus 3 times 3. So 3's are 9. 13 minus 9 is 4. Is my third term 4? Yeah. Okay. So now I have confidence in my TN formula. Okay. So to generate a formula for the nth term of an arithmetic sequence, we use the formula in the log tables, a plus n minus 1 times d. It's solely dependent on what is the first term and what is that common difference, okay? Watch, a very easy mistake is to forget the minus, okay? Just to put your common difference as 3, okay? Don't do that because that's a plus 3, which assumes you're adding on 3 every time, so you will get a different sequence for it. Okay, question 3 then. If 2k plus 1, comma 5k minus 3, and 6k are 3 consecutive terms of an arithmetic sequence, find the value of k. K is an integer, an element of z. Okay, so they're 3 consecutive terms, so they're one term after another. Okay, so again, if we go back to the theory, we have, I could call them, I don't know where they come in the sequence, okay? I can call the middle one Tn, I can call the last one Tn plus 1, and I can call this one Tn minus 1 if I so wish. Okay, so what I'm saying is he could be a Tn, he could be a Tn minus 1, he could be a Tn plus 1. Okay, I suppose rule of thumb always is Tn is in the middle, and then you've one above it, one below it. Okay, it makes the maths a little bit easier when we label them like that, as opposed to calling this one Tn, this one Tn minus 1, this being Tn minus 2. In theory, that's correct too, but just the maths themselves are easier if we label them as such. Okay, regardless, okay, how do we do this? Okay, well, there are 3 consecutive terms of an arithmetic sequence. So therefore, they have a common difference being the same. Okay, so in other words, if I take one of the terms in the sequence and I subtract the one before it, that should be equal to the one in the middle minus the one on the left. So I should get a constant. Okay, so that's how I'm going to tackle this one. Okay, so in other words, 6k minus 5k minus 3 has to be equal to 5k minus 3 minus the term that came before that. Okay, so this term minus this term, okay, because remember we're adding and subtracting the same amount every time. Well, that value has to be equal to this one, take away this one. Okay, so let's figure out our signs here. So I have 6k minus 5k minus is a plus, equal to 5k minus 3 minus 2k minus 2. Okay, so 6k minus 5k is k plus 3 is equal to 5k minus 2k is 3k minus 5. Okay, letters to one side, numbers to the other. So I'll have k minus 3k. I'm just bringing all the k's to the left. And then on the right, I'll have minus 5 minus 3. So I'll have minus 2k being equal to minus 8. Divide by the number in front of your letter. K is equal to 4. Okay, can we test this one? Well, yes, you can. Okay, so what is this term here? So 2k plus 2. So 2 4s are 8 plus 2 is 10. Okay, I'm just writing it down here as a check for myself. So you would always see when I'm doing maths, regardless of whether that's for the college or for for these classes, you'll always see me trying to check my sum to see is it right, okay? And it doesn't have to be fancy. You can see I'm just putting it down here in a corner to check it. So this one, 5 4s are 20, minus 3 is 17. This one, I have 6, 12, 18, 24. Okay, is the common difference between them the same? It is. There's a common difference of 7. Okay, so my k equal to 4 does indeed create an arithmetic sequence because the common difference between them is the same. Okay, 24 minus 17. So do you see that? Tn plus 1 minus Tn, I get 7, and that's equal to Tn minus Tn minus 1. I also get 7. Okay, so I have confidence again that that one's right. Okay, and then on to the last two questions in this little recording. So question 4 then, we're just looking at that sigma notation we talked about. So just to refresh, the sigma notation, where was it, is here. Okay, it means the sum of, okay? And it's another way that you can write out a series. Okay, it's equivalent in a way to the SN formulas. So find the value of the sum of 4r minus 1 when r is between 1 and 8. Okay, so let's write out my first term of that sequence. Okay, so that's when r is 1 because that's what it told me to start r at. Okay. I'm just going to stop sharing there now for a minute because it's kicked me out. Okay, we're back. Okay, so my T1 in this case is when r takes on the value of 1. So that value at the bottom is your starting value for r. So 4r minus 1, so it's going to be 4 times 1. So in other words, I'm replacing that r with 1 minus 1. So 4 1s are 4 minus 1 is 3. T2 is when r is 2. Okay, because literally r goes up from 1 to 8 to give me 8 terms in this particular series. So 4 2s minus 1, so 4 2s are 8 minus 1 is 7. T3, 4 3s are 12 minus 1 is 11. T4, 4 4s are 16 minus 1 is 15. Okay. Again. Ah, okay. 1 sec now. Okay, so we're just doing the different terms of the sequence. So T5 then would be when r takes on that value 5. So 4 5s are 20 minus 1 is 19. Okay, and of course I can do T6, T7, T8 all the way up until r is 8. Okay, but you don't have to do that. You can write out your sequence 3, 7, 11, 15. You know now there's 4 between them, dot, dot, dot. Okay, now remember what sigma stands for. It means the sum of, okay? So I need an SN formula here, okay? I need to sum up the sequences. And do you know what? I'm going to do it both ways just in case you're new to sequence and series so you can see what's happening. So 3, 7, 11, 15, 19, 23, 4 to 5, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Or is equal to 1, 2, 3, 4, 5, 6, 7, 8. I've gone one too many, haven't I? 1, 2, 3, 4, 5, 6. Okay. So when it's what sigma means is add them up. Okay, so 3 plus 7 plus 11 plus 15 plus 19 plus 23 plus 27 plus 31. Okay, I'm going to put that into my calculator now. 31 plus 27 plus 23 plus 19 plus 15 plus 11 plus 7 plus 3. And I'm getting 136, assuming I put it into my calculator right. Okay, now I'm just going to move question 5 onto the next page, guys, just to give us a bit of space. Okay, so that's one way of getting sigma. Okay, so that should be my answer. The more common way it's done, though, is that you would write out a couple of terms in your sequence. Okay, 3, 7, 11, ... Okay, and you would especially do it this way if you had a lot of terms in your sequence, because you can see, or it was a complicated formula, you can see it takes a little bit of time to write out all the terms and add them up. Okay, so you would then use sigma is the sum of. Okay, so you would use the SN formula that's in the log tables for the sum of a number of terms. Okay, so n over 2a plus n minus 1 times d. Okay, that is in the log tables on page 22. So how would you use it? Well, you see the letter A is in it, you see the letter D is in it. A is always your first term. Okay, so you get that from T1. Your common difference then, D, is the difference between all of these. So you can see we're going up in 4s every time. Okay, so it's T2 minus T1 or T3 minus T2, whatever. Okay, and have I a finite series here? Have I a set number of terms? Yes, I do. I have 8 terms. Okay, so in fact, 8 is n in this case. So let's sum those first 8 terms. So it's 8 over 2 times 2 times the first term plus 8 minus 1 times 4. So 8 over 2 is 4. 2 3s are 6. 8 minus 1 is 7. 7, 14, 21, 28. Okay, so that's 4 times 28, 29, 30, 31, 2, 3, 34. And I do get 136 from it. Okay, which is what I got when I added them. So that's what sigma means. That's what the maths language means. And you can see it's a really neat way of writing out the question. Okay, I suppose you just have to be able to read the maths language from it. Okay, but whether you do it as such or you do it as such, it doesn't really matter. I tend to hop between them. I tend to use that for the really simple sequences, and then I would switch down here for the more difficult sequences. Okay, and then a similar question, but a different question. Question 5 says, for what value of n is this sequence equal to 90? Okay, so how many terms of this sequence do I need to sum up to give me 90? Okay, well, again, the easiest way to do it, well, there's 2 ways. You can either start writing out all the terms of the sequence and then keeping a rolling count until you add up all the terms to 90. Okay, that's a little bit cumbersome. Or you can establish your SN formula and solve it for n. So how many terms gives me 90? Okay, so I'm going to do it this way because it's the I suppose, the savvier way of doing it. But to do that, of course, I need to know what is A, my first term. I need to establish what is my common difference. Okay, so to do that, I need to write out a few of the terms of the sequence. Okay, so my first term, T1. So that is when OR is 1. Okay, now just a note, OR doesn't always have to start with 1. In theory, it could start with 0, it could start with 2, it could start with anything really. Okay, 1 is common, but it doesn't have to be 1. Okay, so when OR is 1, I get 3 times 1 minus 5. So 2 1s are 3, minus 5 is minus 2. Second term in my sequence, and I have to do more than one term because I need to see that common difference. Okay, so OR is 2 in this case, minus 5. 3 2s are 6, minus 5 is 1. I tend to do 3 or 4 terms to make sure that I'm not making any mistakes. In other words, I'm making sure that I have the common difference all the way down. Okay, so T3, 3 times 3 minus 5. 3 3s are 9, minus 5 is 4. And T4, 3 4s minus 5, 3 4s, 4 8 12 minus 5 is 7. So plus 3, plus 3, plus 3. Okay, so my sequence, minus 2, 1, 4, 7, dot, dot, dot. A is minus 2. My common difference is plus 3. And you'll most of the time see me putting in the sign with that common difference, okay? That's because back in the day, I would have forgotten the minus every now and again. So I suppose I developed this habit of always writing the sign with D to stop me doing that. Okay, so I want to know how many terms do I have to sum up to give me 90. Okay, so let's sub in what we have. We're solving for n. 2a, so it's 2 times minus 2 plus n minus 1 times d, which is 3. Okay, so n over 2, 2 times minus 2 is minus 4, and then I'm going to multiply 3 by n, so that's 3n. 3 by minus 1 is minus 3. That's equal to 90. N over 2 times minus 7 plus 3n is equal to 90. Multiply that in, so it's top by top, so I'm going to have minus 7n over 2, and again top by top, plus 3n squared over 2 equal to 90. Okay, I'm just going to go on to a new page now, so I'm not squishing anything. Okay, so that's where I'm at. Okay, I'm going to multiply across by 2. What do you think to get rid of all those fractions? So minus 7n, let's multiply across by 2. Minus 7n plus 3n squared is equal to 180. It's definitely looking like a quadratic, so an squared goes first. Minus the 7n, bring over the 180. Okay, A is equal to 3, B is equal to minus 7, C is equal to minus 180. So minus b plus or minus the square root of b squared minus 4ac all over 2a. Of course, you could have solved this using factorization if you can see them. And note that I'm writing n is equal to. The log tables would say x is equal to, but that's just a generic name, okay? So it's always the letter in your quadratic that you're solving for here. So then n is equal to minus b, so minus 7 plus or minus the square root of minus 7 squared minus 4ac all over 2 times 3. Okay, so then n is equal to 7 plus or minus, so I'm hitting the square root sign. I'm putting all that's under the square root into my calculator, and I've got 47 all over 2 3s are 6. Let's split them. So n is equal to 7 plus 47 over 6, or n is equal to 7 minus 47 over 6. Okay, so hit the fraction button first. Okay, the bottom one doesn't really matter because I get a minus term, and you can't have a minus term in a sequence. Okay, you can't go back before the first term. So the answer is the nine terms. Okay, so you had to sum up 9 terms in this sequence. So minus 2, 1, 4, 7, 10, 13, 14, 15, 16, 17, 18, 19. You had to sum up 9 terms to get 90 as the answer. Okay, so that's how you do those particular ones.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in Maths to qualify. Check out the link below.